This is part 3 of the Unit 11 test for chemistry, or the Unit 11 notes for chemistry on concentrations of solutions. Now, when you talk about solution concentration, we can talk about a concentrated solution where the measure of the amount of solute per given amount of solvent. And so if it's concentrated, there's a large amount of solute. But if it's a dilute solution, there's a small amount of solute. So when we talk about its specific concentration, it's really just how much solute is in a given amount of solvent. Now when we do molarity, molarity is an equation that we use to calculate concentration. And we could say that a 1 molar solution has 1 mole of solute per 1 liter of solution. Or if we said a half of molar sodium chloride solution would have a half a mole of sodium chloride in 1 total liter of solution. So molarity, like I said, is always going to be equal to moles of solute divided by the liters of the solution. So to make a solution of a known molarity, you need to have a weighted amount of solute. Okay. Then you're going to have a volume meter or marker on a certain volumetric flask. After you have the weighted out amount of the appropriate dry solute, then you'll add enough solvent to dissolve the solute. And then you'll fill it to the appropriate line. For example, in class, you can make a certain concentration of Kool-Aid. And so if we measured out the amount of Kool-Aid we were going to make, so if it was a liter, then we could put it to that mark. We would measure out a certain amount of Kool-Aid in a dry amount, and then we would add enough water to dissolve it and fill it up to that line. So what is the concentration in molarity of a solution? It's made of 80 grams of NaOH in a 4-liter solution. So we first have to change grams to moles, and this is where we'll need to remember that for every 1 mole, it's equal to the molar mass, or the GFM, of that compound. And so we can look up sodium's mass, which is 23.0. We can look at oxygen's mass, which is 16.0, and we can look at hydrogen's mass, which is 1.0. If we then add all 3 of those together, that is 40 grams. So that represents 40 grams for every 1 mole. That would cancel out our grams. That then gives us an amount of moles, which is 2 moles of sodium hydroxide. We then could use our formula of moles of the solute divided by the liters of solution. So we take 2 moles and divide it by 4 liters, which would give us 0.5 molar solution. And this is something that you'll need to be able to do for your test. Another way of looking at it is you could start with it with grams over liters and then just change the grams to moles. You now have moles over liters because the grams will cancel out. It's the same math. So how would you make 500 milliliters of a 6 molar solution? First, we have to take 500 milliliters and change it from milliliters to liters. So we would divide by 1,000 to cancel out the milliliters. We're now in liters. We know that 6 molarity is 6 moles over 1 liter. So that is the concentration. That's what that capital M stands for. So now we would be able to cancel out the liters. And we would be able to also know then that for every 1 mole of NaOH, we have 40 grams of NaOH from the GFM. So that would cancel out our moles, and we would end up in grams. So we would need 120 grams of sodium hydroxide. and then we would add that to a 500 milliliter volumetric flask and add enough water to that 500 milliliter mark, and that would make our 6 molar concentration. Now when we do dilutions, we can we're not changing the number of moles, we're only changing the concentration of the general solution. So we're really just changing the volume. So this formula only works for dilutions, but it would be M1V1 equals M2V2. Okay, and so for a lab, we need 500 milliliters of a 6 molar solution, but we're starting with a 12 molar solution. So we have an original molarity of 6 moles and an original volume of 500 milliliters, and we want a new concentration of 12 molars, or we're starting off with concentrated 12 molar, so we need to know what volume of that we need to use in order to make what we need. So we'll use our M1V1 equals M2V2. We'll rearrange the formulas, okay, so that we can solve for what we're looking for. So M1V1 divided by M2 will give us V2. We'll then substitute in what we need to know. 6 multiplied by 500 divided by 12. That'll cancel out the molarity, and we'll end up with 250 milliliters. Okay? That concludes part 3 of these notes, and they will be posted. You can go over them at any time that you would like.